So let's talk about multiclass versus binary. This is specific to classification. Classification results that we've seen up until now, it was either yes or no, ham or spam, loan the money or don't loan the money, male or female. In many cases, you will have data sets that have more than two classes. So maybe you have a data set that has class A, class B, and class C. In a data set like that, you can do classification in a couple of different ways. So multi-class classification, there are specific algorithms that from the ground up are built with an eye towards doing multi-class classification. So what they do is they try to take the examples that you give them and partition the space into mutually exclusive regions. So what they'll do, what the decision boundary for those algorithms looks like, it's basically a fracture of the space. It'll take the space and cut it up into little slices, where each slice corresponds to one class and one class only. So now, these algorithms assume that classes don't overlap. What that means is a single individual or a single instance can belong to one and only one class. So it's either A or B or C. It cannot be both A and B. Also, these algorithms assume that there are no other classes in existence. So you don't get to have a D. If D was not in your training data, if you didn't have any examples of Ds, then D cannot possibly exist, even if D doesn't look like any of those examples, even if it's an outlier. I guess, and we'll cover a few different algorithms that fall into that. So naive Bayes, nearest neighbor methods, all kinds of decision trees, and logistic in its basic form. The softmax extension to the logistic. They're multi-class classifiers. That's what they do with classification. Now, binary classification is a little bit different. We have some algorithms that cannot do that, and unfortunately, they are actually the most powerful algorithms that we have. So when we talk about the support vector machine is fundamentally a binary classifier. It draws a binary between positives and negatives. That's what it can do. That's what it's designed to do. So if you have multiple classes, what you end up doing in that scenario is you end up doing one versus the rest kind of training, right? So I'm going to take class A, and then I'm going to take everything that is not class A, and I'm going to build a classifier just for determining A. So all the A's are going to be positive, and all the B's and C's are going to be negative. And it will learn a boundary to separate A's from not A's. So I can do it for A's, I can also do it for C's, right? C's versus non-C's, or B's versus non-B's. And of course, what I'm doing here is I'm learning each class individually and separately from the rest of the classes. So the interesting consequence of doing that is once I put all of these decision boundaries together, I have a lot more combinations than I had previously. So first of all, classes now can overlap. If I had a data point right here in the upper region, that would be positive for class A, because it's on the same side as the A's. So if you look at the red decision boundary, it's on the correct side of the red decision boundary, so it would be labeled as A. It would also be labeled as C, because it's on the positive side of the green decision boundary. So a point right there would be labeled as both A and C. And if you wanted only one label, you would have to introduce an external rule, something that is not a part of the classifier, something on top of the classifier that would decide, well, okay, it's both A and C, but which is it? Do I have any other criteria to decide between A and C? Or you might have a task where you actually want that, right? So maybe A and C are different tags, like classical and techno. You could have a classical techno piece, in which case this would be a good classifier, because it would say, yes, it's classical, and yes, it's techno. Binary classifier also allows you to have an area where none of the labels apply, right? So if I have a data point falling into this central region, this central triangle, that would be classified as no for all the classes that I have. It's not an A, it's not a C, and it's not a B. So you could have an instance that doesn't look like any of the classes that you have. So if you had a class D, which happened to fall in here, you'd actually do the right thing for it. You would say, no, it's not A, no, it's not B, no, it's not C, I have no idea what it is. Right? And sometimes you want that. And as I mentioned, support vector machine is that kind of a classifier. Perceptrons and neural nets are that kind of classifiers. And logistic in its basic form, without the softmax, is also a classifier that does exactly that sort of thing.